Hi, this is Tim. Today we're going to talk about how to configure the high-speed counter function file in Allen Bradley's Micrologix PLC. These function files allow you to do time-sensitive tasks that you normally wouldn't be able to do in standard ladder logic. Now I know a PLC seems like it scans fast. I'm just going to wildly guess that our scan time is somewhere around 5 milliseconds. So there, just like that, we scan like 200 times. But let's say you have an encoder such as this one, which is a 1,000 count encoder, and it's coupled to the back of an 1,800 RPM motor. That means this thing's putting out like 30,000 pulses per second. So our 200 scans per second isn't going to be able to keep up with this. But using the Micrologix high-speed counter function file, you can actually count pulses up to 40,000 pulses per second. So it'll catch this. For this video, we're going to use one of our standard PLC trainers, and we're going to use this encoder simulator. This is the SIM-EOC. This encoder simulator has an open collector output. Now I can connect a standard encoder to it and show you that. The disadvantage is, while I'm trying to talk to you about things, I'd have to be sitting here doing this the whole time. And that's the advantage of the encoder simulator, is it can simulate 10 hertz, 100 hertz, 1,000 hertz, or 10,000 hertz. And a hertz is a cycle per second. So that means 10 times a second, 100 times a second, 1,000 times a second, or 10,000 times a second. So we'll be able to show you a lot more of what you can do with the high-speed function file with this. Now the high-speed function file uses inputs 0 and 1 for channels A and B of your encoder. All right, so we're going to wire our encoder simulator into our Micrologix. One really nice thing about it is it is general mounted, so we'll go ahead and snap it down. We'll connect 24 volt to power the simulator. And that goes to the B plus terminal and the COM terminal on the bottom. Then we'll connect the A plus terminal to input 0. The B plus terminal to input 1. Then the DC COM for the inputs 0 through 3 goes to plus 24 volt. When you look at the LCD screen, you may or may not see the inputs, and that's because they are flashing at a very high rate, and the LCD screen doesn't actually give an instant representation of what the IO states are. So we're going to look in the program to see that. A little bit about the encoder simulator that we're using. It has 10 hertz, 100 hertz, 1,000 hertz or 1 kilohertz, and 10,000 hertz or 10 kilohertz. And you can see right now we're on 10 hertz. When it is solid, it's not actually sending out pulses. So it's the same as your encoder sitting still. And if you hit the direction button, it'll start blinking slowly, and that is clockwise. And then if you hit it again, it's doing a double blink, and that means it's going counterclockwise. And if you hit it again, then it'll be stopped again. So now we're going clockwise, and we hit the frequency button. That takes it to 100 hertz. If we hit the frequency button again, it takes it to 1 kilohertz. And if you hit the frequency button again, it takes it to 10 kilohertz. Now let's create our RSLogix program. We're going to click New, give your processor a name, and we have a 1763. That's a Micrologix 1100, and ours is a Series B. And also on ours, we have an analog module, so we're going to go to our I/O configuration, and we're going to add a 1762 IF2OF2. And let's click our channel configuration, because our Ethernet we want to set up. We're going to disable boot P, and our Ethernet IP address is going to be 192.168.110, and our subnet is going to be 255.255.255, and that'll be enough to get us going. And now let's open up the function file, and the default tab is the HSC, or high speed counter tab. And you can see the first parameter is the PFM program file number. And what this is a ladder file that is associated with this function file. So we're going to go and right click program files and click New. And the default is ladder 3, and that's fine. And we're going to give it a name of HSC. You don't have to give it that name, it's optional. And this will actually have no code in it. It is just there for this function file. So then we will put that program number, which was 3, in the program file number. We're going to put a 1 in the user interrupt enable. We're going to put a 1 in the function enable. We're going to put a 1 in the auto start enable. And we're going to put a 1 in the counting enable. Now I know I went through those really fast and didn't give a lot of a description of them, but if you just hit F1 right here, it will bring up a very good description of those parameters. Now the one parameter that still needs set is our mode, and we are going to take a few moments to talk about the mode, because there are several modes that you could do here. In fact, let's go ahead and hit F1 again, and let's scroll down to the mode. And you can see we're going to use the mode of quadrature counter, phase A and B inputs. We could also use the mode of quadrature counter with an external hold and reset. And what this does, this will assign the external reset to input 2 and the external hold to input 3. Now at first you're going to think, well, I ought to do that because it has more capability, but it ties up those two inputs. And it's not completely clear that they are used. And I did this one time, that's why I want to share it with you, is I did the same thing. I selected mode 7 because it had more features. I forgot about it. And then later I needed to add an input for something completely unassociated with the high-speed counter. I looked in the program, I saw that input number 2 was free, I connected it to it, and we started having erratic issues with the high-speed counter. Or it wasn't erratic, it was every time that input 3 would turn on, it would hold the value of the counter. So unless you're going to use an external hold and reset, I would leave that out. I would just go with mode 6, and that's what we're going to do. And now our high-speed counter is configured, except there is one super important thing that still needs done. And this is absolutely the number one thing that I still forget to do when configuring a high-speed counter. It's also the number one thing that I get calls about from people that can't get their high-speed counters to work. And that is, we need to lower our input filters. And so to do that, we're going to go back to our I/O configuration. And we're going to click on slot 0, Bulletin 1763 Micrologix 1100 Series B. And you would think that you could just go to the embedded I/O configuration and change your input filters. But you can see it's grayed out here, so you wouldn't think to do it. But if we go back to our embedded general configuration and we select a base type. Now your base type is the last 3 digits of your PLC part number, which in our trainer's case is BBB. Also note that an AWA will not work because that's an AC input PLC and you can't use AC inputs for encoders. So it needs to be either a BWA, a BBB, or a DWD. But once we select the BBB base and we go back to embedded I/O configuration, now we can select our input filters. And we're going to put them down at the 12.5 microseconds. Now if you don't do this, what will happen is your high-speed counter will work at low speeds. But these input filters are mainly to try to make the PLC more noise immune. Well, the PLC can't really tell the difference between noise and a high-speed counter because it is really high frequency pulses. So the default one, you would see it at low speed, it would count fine. But the faster you go, all of a sudden you would either miss counts or the counter would quit working. So we lower those to 12.5 microseconds. And now our high-speed counter is configured. But we're going to add a little bit of code into the main program of our ladder logic just to show that it is working. Now first, make sure you are in ladder 2, not in the ladder 3 that we created for the high-speed counter. And we're going to go to the Move Logical tab, and we're going to use a move instruction. And our source is going to be HSC:0.ACC, and that is the accumulated value of the high-speed counter. Now this high-speed counter is a 32-bit number, and our integers are only 16 bits. So we're going to go to Data File, right-click it, and select a new, and file 9 is fine, but for type, we are going to use a long type, and this is a 32-bit integer, and you could name it something, and let's just go ahead and put 10 of those in there. And now you can see there's our L9 long. And so for our destination here, we're going to put L9:0. All right, and that's it. Our counter configuration is done. So now we're going to download our program. And if you don't remember, or if you're not sure how to download your program, I'll put links in the description. We have videos on how to download, how to configure your serial connection, how to configure your Ethernet connection, and how to download your program. So we've downloaded it. We're going to switch to run mode and we're going to go online. We're going to start at 10 Hertz, which is 10 cycles per second. And we're going to hit the button. So as you can see, just about every second, we're getting an increment of 10. So that is 10 Hertz. And now we can hit the frequency button, and that's going to be 100 Hertz. And if I hit it again, now we're doing 1,000 Hertz. And you can look and see, it's about every second, we're ticking away one on the thousandths. And then this is 10 kilohertz. And then we can reverse direction. Actually, there we hit it again, and it's going to stop. And then we hit it one more time, and we're going to start going down in directions. This would be your machine going backwards. So there you go. You have your counter configuration. Now, there's a couple other things I want to talk about here. Is first, all right, we have this value here. Well, what if we want to zero it? Well, we're going to use the online edits to do that. We're going to add another rung. So we go to our user tab. It's going to be right there. And then we're going to look at, let's just say an internal bit. So we're going to XIC B30, and we're going to call this counter reset. And then what we're going to do is we're going to go to the micro high speed counter, and you're going to see this RAC, which is it's reset accumulated value. And it defaults to the high-speed counter 0. And our source, we can just put a 0 there. We're going to accept that. We're going to go ahead and test it. And then we're going to assemble that. And right-click, we're going to toggle that bit. And you can see our high-speed accumulated value went to 0. Now, some of you are probably wondering, okay, but can I do this in ladder code? I still don't understand why I can't do it in ladder code. Let's add a rung to show the difference between using the high-speed counter function and trying to count in a ladder program. So we're just going to use input 1. We're going to go ahead, let's go back to our user tab, and we're going to insert another rung. And XIC, we're going to go for I:0 \0. Now, one thing to note is we have not needed to actually put input 0 or input 1 anywhere in our ladder program to make what we have work so far. But let's just call this channel A. And then we're going to use a one-shot bit. And we'll just go for B31. And then we're going to put an add instruction in. So we'll go over to the Compute Math tab, add, and our source A, let's put as L9:1. And this is going to be, let's just call it adding counts, because that's what we're going to do with that. And the source B is going to be 1. And then their destination is going to be that same L9:1 that was source A. And what this is going to do is every time that it sees channel 0, it's going to add a 1. And we're just going to see how closely they follow each other. So we're going to go ahead and accept that, and then we'll test it and assemble it. All right, let me see if I can at least hide some things and maybe get this where you can see all of it. Let's take the standard toolbar out, the online toolbar out, and all right, that gets us a little closer. Oh, close. Well, you can see the L9 here. That'll be L9, and you can almost, let's zoom out a little bit. Actually, that's really smart. Let's just click this rung, drag it up. That way they're right side by side. We'll go ahead and assemble that. There you go. Now you can see both of them. All right, so now we have it set. So our function file accumulated value is at 0, and our ladder counting, which is in L9:1, is also at 0. And we're going to start off at 10 Hertz, and I'm going to hit the direction button, and that's going to be counting. Now we're at 10 Hertz. That's 10 cycles a second. And you can see about every second we're adding around 10 points to that, both of those values, and those values are really close to each other. And the reason for that is if we go over here to processor status and then go to scan time, we can see our scan time here. This is a representation of 100 microsecond of the scan time. So I'm seeing a value of about 8. So that's about that ends up being about 800 microseconds, or a tenth of a millisecond. I see it bouncing somewhere, I'm guessing into the teens occasionally. So let's say we have a maximum scan time of somewhere around 2 right now. So there's 100 milliseconds every second. So in theory, we can count up to around 500 pulses this way. And that's why you see these are sticking really nice and close to each other. So now I'm going to reach over here and I'm going to hit the frequency button, which is going to take up to 100 hertz. As you can see, every second we're adding about 100 pulses to both values. And these values, I mean, they're close enough that I can't tell which one's leading or lagging right now. But here's where it's going to get really tricky, and you're going to start to see the advantage of the high-speed function file. Is I'm going to hit the frequency button again, and I'm going to bring it up to 1,000 hertz. And now you can see the add button here is starting to lag behind. And the reason for that is our quick math we did off the scan time says that we can handle about 500 hertz. And now we're at 1,000 hertz, and we're missing about half of the counts. But our high-speed function file, which can handle up to 40,000 pulses a second or 40 kilohertz, is still counting. And if we hit that frequency button again and get to the 10 kilohertz value, you're going to see now the high-speed counter is really accumulating values fast, and our add is still going about at the same rate. And I'm wildly guessing this rate that you're seeing right here is around 500 hertz, maybe even a little less, because now it's going high and it's going low, and sometimes it's scanning and all it's seeing is the low value. So that is the advantage of using the high-speed function file for things such as encoders, as opposed to trying to count them in ladder. Hope this video has been helpful. I think we will continue this series because we've had a lot of interest in it, and we'll probably start talking about how you can, maybe we'll use our servo simulator and show how we can take an analog output and vary the pulses. So right now we're using fixed frequencies, which are really good for testing, of 10, 100, 1,000, and 10,000 pulses. Well, we could actually take our servo simulator and using a 0 to 10 volt signal, we could vary the output of that pulses. And there's a lot of neat applications you could do with that. Please don't forget to like this video, comment down below on what you'd like to see next, and be sure to subscribe. We put out at least one lesson a week, and we also try to put out some type of how-to like this. Till next time. Hi, this is Tim.
And this is Amber of TW Controls.
We run the automation store.
Be sure to subscribe for more great videos.
And like this video and comment on what you would like to see next.
Visit our website where we offer a full line of PLCs, simulators, control panels, PLC trainers, and more.